Okay, so 2 lessons ago we learned about the sine rule, and today we're going to learn about the cosine rule. And they're both used to find either an angle or sides in a triangle, depending on the information you're given in the question. Most of the time you'll be asked you'll be told which formula to use, but for a higher level question, it's going to be up to you to determine which of those rules that you need to use. So in relation to this particular rule, we're looking for a situation where we have and it says here 2 sidelets. What we mean by that is the 2 sides that touch the angle that we're concerned about. So there we are. We have 2 sidelets and we have an angle, and we're going to also be looking at the opposite side. So for this particular rule, for today's lesson, we're going to be looking at situations where what we're trying to find is the opposite side. We'll always be given these sidelets, so the 2 sides that come off the angle will be given those, and we're given the angle and we'll have to find the opposite. Tomorrow's lesson, or maybe not tomorrow, but the next lesson, deals with finding that angle if we have all 3 sides. So as we go through, I'll just sort of point out where it's different from the sine rule. Now, it looks a little bit more complex, but in the end, it's a formula that's on the formula sheet. You just have to be able to know which sides are which and substitute in. But much like with the sine rule or the area of a triangle rule, it doesn't matter which sides we call A or B, as long as we get side C correct. Okay, so in this particular situation, this first example, we couldn't use the sine rule here because this angle and that side we don't know the length, and the other 2 sides we don't know their matching angles. So in order to use the sine rule, I need a pair of matching angles and sides and another pair of matching angles and sides, and I don't have that in this particular case. So this is an example where I can use the cosine rule. And the cosine rule just simply says c squared equals a squared plus b squared minus 2ab cos c. Now remember, capital C for the angle, because the angle is displayed with capitals, the sides are displayed with letters. So in this particular case, this here is going to be our side C. That's our angle C. And it doesn't really matter which of these 2 we call A and which of them we call B. It's perfectly fine. It won't make a difference. But make sure you get your C correct. So in this case, we're going to have, well, C is Q, so we're just substituting. So Q squared equals 51.1 squared plus 82.7 squared minus 2 times by 51.1 times by 82.7 times by cos, and the degrees is 58.8 degrees. And so we just substitute all that into our calculator. Now, I'll just make the quick point that I didn't make at the start. If you want to know why this rule works, there is a proof video for this. It is a little bit more complex than the sine rule and the area of a triangle rule. So if you watch that video and you don't quite get it, once again, you don't need to know why they work. You just need to know that they do. So if you don't quite get it when you watch that video, that's okay. You're not asked to prove anything in standard mathematics. We're just asked to be able to apply those formulas. So this is quite a lot to get in my calculator. I've got 51.1 squared. Then I'm going to add to that 82.7 squared. Then I'm going to take away from that 2 times by 51.1 times by 82.7. We're now at the stage where I've covered up what I've got there, and then that's going to be multiplied by cos 58.8. We plug that all into our calculator, we press equals, and we're going to get a big fat number. So that's going to be 5072.167, we'll say. Now, importantly, that's q squared. Obviously, if we look at the lengths of these particular sides that are in our triangle, it doesn't make sense to have a length of another length that's 5,000 units long. So we have to remember that this is for q squared. So what we actually want to find is q. So what we need to do to find that is to take the square root of the number that we just found. So you press the square root button, press answer, and that'll take the square root of your last answer. And that's going to give us 71.2 Now we're finding a distance, so it's going to be in units. It doesn't actually say whether in centimetres or metres or millimetres, so we'll just say 71.2 units to 1 decimal place. So it's really no harder than the other formulas. There's just a little bit more to substitute in this particular formula. But given that you're given the formula, you just have to identify your sides and substitute in. So for our next example, we have to calculate the length of the side P. Well, in this particular case, P is opposite the angle. So if we called that C, then this must be our A and our B. So once we've labelled our sides, there's not much else to do but to substitute into our formula. So our formula says that C squared equals A squared plus B squared minus 2AB cos C. And so in this particular case, the side that we're calling C is called P. So P squared equals 38 squared plus B is 46, so 46 squared minus 2 times 38 times 46 cos, times by cos, actually I'll just change that, 44.3 degrees. And we just substitute all of that into our calculator. It takes a little bit of a while to get into the calculator, but that's really not too difficult to do. So 46 squared minus 2 times 38 times 46 times cos 44.3 degrees. So we're going to get 1057.938. The dots just basically say to the person who's reading this, look, there's other stuff after there. We haven't deleted it from our calculator. So obviously that's found what P squared is, but what we want is P. So that's going to be the square root of that 1057.938 ... And we do that just by using the calculator and press the square root button, then press answer to bring up our last answer, and press equals, and we're going to be left with 32.5, we'll say. Now the units aren't given in the question, so we're just going to say units, not units squared, it's just a distance, so it's in units, and that's to 1 decimal place. Okay, moving right along. This next one is no more difficult than the previous ones. I think I'll leave that as an exercise for you guys to do. Obviously, there's my angle C. I've got an A, I've got a B on either side, and that's going to be my side C. So you should just be able to substitute it into the formula. I'll leave that as a question for you guys to work out on Edpuzzle. And I'll move into the next example so we don't spend too much time doing the same thing. So after that, there's example 4 and example 5 use a little bit of bearing, so I thought that was quite important to understand. Now, let's just go through this drawing and see what we've got. So Lauren has been surveying, she was surveying the width of a cow pasture swamp, and these are the measurements she noted. So she said RT was 150 metres, so that's this side there, that's 150 metres, and RV is 130 metres. And there's a bearing of T from R and a V from R, so from R. So let's just make a north line here so we can work out our bearings. So this bearing here, that's going to be 348 degrees. And the other bearing that's given, I'll do in blue, is this bearing here, and that's going to be 9 degrees. Okay, so we have that information, and now we need to find the width of the swamp, so TV. So this is what we're after up here. We're after this distance up here. Okay, so if we think about this in terms of labelling, this is going to be our C, our angle C down here. That's going to be our A, that's going to be our B, and this is going to be our side C. So first we're going to have to work out what this angle is. So, finding the angle, I'll call this. And really, the easiest way I think to think about this is if it's 348 degrees around to here, then this distance here, that green distance, must be 360 degrees minus 348 degrees. So if we work that out, that's going to be 12 degrees. So what we really need to find is the angle in that triangle. So I'll use a different color again. We'll see how we go here. So what I'm after is this angle here. And that's going to be, if this side is 12 degrees, if the green side is 12 degrees, the blue side is 9 degrees. So I'm going to have 12 degrees plus 9 degrees is going to give me 21 degrees. So now I know that that angle is 21. So therefore, angle C equals 21 degrees. Okay, so now that I know that, I can now start to use my formula. So finding the length, we're going to end up with C squared equals A squared plus B squared minus 2AB cos C. So in this particular case, we're going to end up with our A squared is going to be 130. Once again, it doesn't matter which one you call A and which one you call B, but in my case, just to stay consistent, I called the length of 130A. So 2 times 130 times 150 times by cos, and our angle was 21 degrees. Now I just substitute all of that into my calculator, and
21 degrees Fahrenheit is equal to minus 6.111 degrees.
My stupid phone started making noise. Just 1 second. Okay, so I used that pause to get everything into the calculator. So I've got my whole formula there in the calculator. 130 squared minus, plus 150 squared minus 2 times 130 times 150 cos 21. We press equals. We get a big fat number, 2990.36 ... So C is going to equal the square root of that number. So we pull up our calculator, press the square root of the answer, and we get 54.7. We'll just check what the question asked. Find the width of the swamp. It didn't actually ask us to how many decimal places, but it is in meters. So 54.7 meters. So therefore, swamp is 54.7 meters wide. And there we go. So the final example here, we have a diagram shows Broken Hill, Orange and Narrandera. Orange is on a bearing of 110 degrees from Broken Hill. So let's start by putting that information in. So if we draw a north line here, this angle in here is 110 degrees. And then the bearing from Broken Hill to Narrandera is 155 degrees. So we'll use green for that. And so this angle in here is 155 degrees. Okay, Heather was 380 k's from Broken Hill on a flight to Orange. So she's not in Orange. It's not 380 k's from Broken Hill to Orange, but she's heading in the direction of Orange. And her plane lost power, and she had to crash land. And the closest search and rescue plane was at Narrandera. How far was it from Narrandera to the crash site? So this is our unknown. This is our C here. This is the bit we want to find. We know that it doesn't say so in the question, but the information in the picture tells us it's 300 kilometres from Broken Hill to Narrandera. So what we actually have here is our A distance and our B distance. So what we're going to need to know is we're going to need to know this angle C. So we'll start there, angle C. Well, that's just going to equal the difference between these two bearings. So to find this area in here, I just need to take away those two bearings. It's 155 minus 110 degrees. So that being the case, that's going to be an angle of 45 degrees. Once we know that, we can just start substituting into our formula. C squared equals A squared plus B squared minus 2AB cos C. Now I'm about to run out of time, so I'll leave that as an example again, but once you know the angle, it's pretty easy to work that out from there.